So for my project, I created a automatic DCDT calibration device. Okay, so the problem is that we often have to use the DCDTs in the rock mechanics lab to calculate the displacements of the horizontal and vertical rams. And we have to calibrate these guys on a periodic basis to make sure that we are calculating the correct displacements and to make sure that the range that we're working with is, that the DCDT is linear over the voltage range that we're working with. So currently, the way that we do the calibrations, you can see Shrine here is really enjoying life doing this. But the basic idea is just to have a ring stand, and which holds your outer part of your DCDT, and then while you just move the core throughout the voltage range. And you do this in 1 millimeter increments, and then record the voltage at each position. So, but this is kind of quite time consuming, especially if you have to do it for a lot of DCDTs and for different gains. So my idea was to create a device that would just automatically move the DCDT for you. And the only thing that the user or the person doing the calibration would have to do would be to just record the voltage. So to solve the problem was kind of a two-approach part. The way to solve the problem was to try to figure out how to hold the DCDT. So the way I did that was just create a 3D print of a bracket, which is shown on the right. So the basic components of the bracket just consist of a cylindrical holding device that you can just put the DCDT down into, and you can slide down in there, and then there's screws on the opposite side that you can tighten it down to get it in there or take it out. And then on the sides of the bracket, there are two mounting holes for the linear ball bearings that I have mounted on there. And then on the top portion, there is another set of holes that I use to screw the eye bolts through for connecting my belt to the bracket. So to get the bracket to move up and down, I created a frame made out of plywood, and then 2 aluminum rods for the bracket to slide up and down. And then the bracket is mounted to these linear ball bearings down here, and so I can just mount my bracket and then screw it on there. And then the bracket itself is moved through a stepper motor and a driver and then a belt and pulley system. So the belt itself is connected to the bracket through a set of eye bolts, and I just loop the belt through the eye bolt and then back around the pulleys and into themselves. And then I have a little adapter at the top here for mounting the core. So my system is powered through a stepper motor. I'll just kind of give you a very brief outline of how it works. So basically, a stepper motor is just a DC electric motor that moves in discrete steps. And then the basic components consist of a permanent magnet, a rotor that's permanently magnetized, and then surrounding the motor, or the gear, are a set of stators. And then the stators are organized into groups or phases. So for mine, it's a 2-phase motor. So for each phase, there's actually 4 stators that correspond to each one. And then, so to get it to move, if you apply a voltage to the windings, then you can control the direction of current flowing through the windings. And then at any given time, you can assume that, like for instance, the phases on A will, the teeth on the stator will align perfectly with the teeth on the gear. And then if we just alternate the current direction in phase A, then it'll essentially rotate the gear 1 step, and then now the teeth on the gear will be aligned with the teeth on the stator for phase B. And then, so this constitutes for 1 step. And then for my motor, it goes 400 steps per revolution. And then we can actually increase this precision through doing half stepping or micro stepping, which is just breaking down the full steps into finer increments. And then, so the way that the motor works is through the driver. So from the Arduino, I can send the commands to the driver to tell it how many steps to take and then what direction to take. And then, so for my driver, it's a micro-stepping driver, and it's defaulted to go in 1/8 steps. So it comes out for my motor that it's like 3,200 steps or positions for one revolution. And then the velocity and the torque on the motor is just depending on how much current you're applying to the motor windings. So currently, for the way that I had the operation set up was to have the bracket move 1 millimeter and then stop for like 5 seconds, and then move another millimeter, stop for 5 seconds, and then go for 30 millimeters distance. And the idea was so if you move in 1 millimeter increments, you can move, stop, and then record your voltage, move another millimeter, and stop, record your voltage. And then 30 millimeters is just a random number that I put for like the entire range of the DCDT, but you could change this or any of these other parameters in the code to suit the DCDT that you're calibrating. So the main problems that I encountered while working on this project, so there were some minor issues when I first was hooking up the driver, like the voltages coming out of the driver were inconsistent. So this was just a problem with the soldering issues, and the soldering connections were not that great. And then the majority of the other problems come with just the assembly process, so trying to make the bracket move. I was unsuccessful in doing it at first, and a lot of the problem was the fact that the pulley was slipping on the belt. So just by tightening up the belt, this helped this problem. And then also there was a slight misalignment in the bracket in the way it was mounted on the aluminum rods, which is causing it to kind of stick as it moved up. And then the way I had the pulley mounted on the very top, it was actually clamping down on the pulley, and it was causing it not to rotate smoothly. And then I guess I can put this guy up.
You need to plug something in, or? So you're not going to report out of this right now, you just have this sort of demo.
Yeah.
Do you have your USB?
Yeah.
Does it matter which USB you use?
No. So now I have it set to where it'll move, and it goes like down 2 millimeters, and then stops. And then, so just for the demo, I only had it set up to do a total of 10 millimeters. So it goes down, and then it'll move back up after it's gone 2 millimeters. Or 10 millimeters, it moves in 2 millimeter increments at a time. So you can change like all of this in the code if you wanted to get it to move however precise you wanted to get it to go. Yeah, I don't know, it seems to be pretty smooth whenever it moves up and down. I'm not sure exactly what the exact precision is, like every time it moves. It seems to be pretty accurate, but I don't have an absolute uncertainty on that. Yeah, I mean that's pretty much it. I think.
Nice, very nice. Questions?
Sorry, I just, I'm not sure I quite get it. So how does it calibrate by itself, or you read the voltage every 2 millimeters and then calculate the thing, or it just, I don't know.
So yeah, so the idea is just to have it set up where it'll move 1 millimeters, or right now it's moving 2 millimeters, and then this will be hooked up so you can read your voltage coming out, and just to move it in steps of 1 millimeter and then record your voltage. So like the same kind of thing that we did in the class, but rather than having to move it up manually by yourself by turning that little thing, the idea is just to have it automatically done for you, and then the only thing that you have to do is just record your voltages from whatever you're recording your voltage at with.
So does your Arduino system can like record voltage your computer right now, or?
No, I don't have it set up where it'll go, like the voltage reads into the no.
I see.
Yeah, but that's something you could add on. Yeah.
Right.
Yeah. Robert, what are you gonna say?
That's my question. Is it heavy if I'm recording voltage?
Yeah, I don't have it set up to do that.
Can we be animated, even DC?
Yeah, sure.
And I guess you could include a way to measure the displacement more accurately if you didn't end up, you use this as an automatic way of moving it, and then as far as exactly how far you moved it, you could have another system to measure that. Yeah.
How many man hours went into that approximately?
It didn't take a whole lot of time. Like the frame itself didn't take very long. I spent most of my time just trying to get it to move up and down. Like when I first set it up, like I said, like it wasn't working, and then so I spent like a day trying to figure out why it was not working. And then once I got it to work, it wasn't really that bad.
How much did it cost?
I think.
Do you have a cost sheet?
No, I think all the parts were like around 50, and then the wood was like, I don't know, maybe like altogether maybe